Hello, and welcome to this supplementary lecture for the Preliminaries unit in Phys 1104. This video is to show you an example of an order of magnitude calculation. Here's the general process. You start with some sort of a simple model. You want a simple equation, and in particular, you're interested in knowing what variables the target quantity that you're trying to find depends on. Once you know what those variables are, you should try to estimate the values of them, just their orders of magnitudes, but you should have picked a model where it's reasonably easy to estimate these values. Lengths and times are often the easiest things to estimate, so if you can reduce everything to estimating those, that's probably a good choice. In the end, you calculate, but that's the easy part. The difficult part would have been estimating the values of the variables. We're going to estimate the volume of water in Sydney Harbor. Now, first off, realize I have no idea what the volume of water is in Sydney Harbor, and if I were just to guess, I would almost certainly be very wrong. An estimate is not a guess. The point of an estimate is that you make a simple model that you use to calculate what you're trying to estimate from things whose values that you think you can guess reasonably well. So I'm going to make a simple model of Sydney Harbor. I'm going to say that it has some length that I'll call little l, and it has some width that I'm going to call w, and it has some depth d, and I'm going to say that the volume is just roughly the length times the width times the depth, which means I'm modeling it as just a big kind of rectangular box. Well, that's certainly wrong, but if I just want the rough order of magnitude of the volume of water, this should get me there. So I'm going to start with the length, because I think that's the easiest. Because you've probably, at some point, driven from Sydney River up to New Waterford. And chances are the drive took you, I don't know, maybe half an hour or so, and you were probably going about 50 kilometers an hour most of the way, and so we could guess that's maybe 20 or 25 kilometers. So I'm going to say that this length is about 20 kilometers, 2 times 10 to the 4 meters. I'm going to work all in meters to keep things consistent. Next, let's think about the width. Well, what might it be? It's certainly a lot bigger than a football field, right? And that's 100 meters. So is it more like 1 kilometer? Or is it more like 10 kilometers? It's certainly not more than that. Well, a useful thing to know is that if you're looking over water or flat land like the prairies or something, the horizon is around about 5 kilometers away. And if you're standing over here in South Bar looking over at North Sydney, it is not off on the distant horizon. So I'm going to say that it is closer to 1 kilometer, and so the width is roughly 1 times 10 to the 3 meters. Okay, the depth is a little harder, right? 1 meter? I doubt it. 10 meters? Well, maybe. 100 meters? Well, maybe. It's certainly not a kilometer. Well, I think it's about 10 meters, and here's my reasoning. They've had to dredge it to let big ships come in. If it was typically 100 meters deep in most places, they wouldn't have had to dredge it. So I think the depth is about 10 meters. And so now I can estimate the volume, because it's just the length times the width times the depth. And that's 4, 7, 8. So 2 times 10 to the 8 meters cubed. Whenever you calculate any number, you should always think about it and make sure you believe it. So for example, if you're calculating a speed, you might compare it to speeds you know, like walking speed, speed on a highway, things like that, to get an idea of how it compares. So let's compare our answer for Sydney, Nova Scotia's harbor with something we can look up, like the volume of Sydney, Australia's harbor. So Wikipedia, which for something simple and factual like this is probably pretty correct, says that the Sydney, Australia harbor is 562 million meters cubed, and so that's 5.62 times 10 to the 8 meters cubed, and so we're in the same order of magnitude, and that means our answer is probably pretty believable.